Hi, I'm Metta Spencer, and today we're going to talk about buildings. You probably are in one. I certainly am in one, and I expect that we're exuding all kinds of terrible greenhouse gases into the environment just by living here. I hadn't thought about it until recently, but it seems that buildings are a major cause of greenhouse gas, which is the main cause of global warming. So we've got to do something about that, and I decided I'd better talk to an architect. And in addition, we want to talk to somebody who knows about carpentry. So here we have two gentlemen who are going to talk to me. We're just getting acquainted. One is Paul Dowsett, who is the principal architect of an organization called Sustainable. That is an architectural firm on Queen Street in Toronto. And we have opposite him, sitting in a gray chair, Michael Yorke, who is the president of the Carpenters District Council of Ontario. Paul, I'm going to let you set the agenda for us, what we should consider when we look at the nature of the materials, I guess, that we use.
Okay, that's an excellent beginning to this conversation, Metta. Thank you for that. Yeah, you're absolutely correct. We need to look at the materials that we build things out of, and we need to look at the carbon content of those materials. The carbon that is emitted both, in the extraction of the material, and then in the manufacture of the material, and then the use of the material in the building itself. And to that end, that's why our firm are huge proponents of the use of wood. Wood, when it's in the wood factory in the forest, when it's becoming lumber as a tree, of course, it is consuming carbon dioxide and emitting oxygen, which is fantastic. I mean, that's really one of the best factories in the world that you can imagine. Mm-hmm. A totally non-polluting factory, a factory that is drawing down carbon from the atmosphere.
Forestry as probably the most useful thing that we can be doing right now.
So a properly managed forest, the forester knows when to cut the tree down, at the end of its adulthood and at the very beginning of its old age. That's the point at which we should be cutting the trees down and making room for the new growth to come up in their place. I'd be interested to hear what Mike has to say. He probably talks to more people who know about forests than you and I combined, maybe.
All right, let's go.
One thing I would say is that I think that there's great value in, as Paul has mentioned, a properly managed forest system. So that can mean planting the trees. That's going to mean working with these trees as they're going. It also means harvesting those trees and using them in an appropriate system of manufacturing, and that's the beauty of something I think we're going to get to a little bit later in this conversation. That's around the mass timber component of construction and new technology using an old material in new ways. So as an example, I would say in Austria, they've had property and forest management systems protocols in place in legislation for well over 300 years. And so I think that Ontario and Canada can learn a lot from that, and we can implement some of those ideas that have been tried and tested.
What do they do that's different in Austria?
Well, I mean, I would say one thing is that I think a lot. So one thing that was said to us by one of the icons of the mass timber sector, he said, in Canada, you have massive trees that you harvest and you chop up into all kinds of small pieces, 2x4s, 2x8s, etc. He said, in Austria, we don't have trees like that. So when we harvest, we take smaller trees and we make massive timbers. So through glue lamination, through CLT, through different systems, they're making massive beams and floor slabs, wall slabs that they've been working on this process for 25 or 30 years. In Canada, it's only in its infancy, and you can see some bright lights in Quebec and in British Columbia. Ontario, we're kind of behind the curve. But we have huge resources in Ontario that I think we have yet to really develop and explore. So I'm an advocate for this process.
Okay. That very interesting. It does sound bass-ackward, you know. If we have big trees and cut them into little pieces, that doesn't make much sense. However, let me try. It looks like I'm going to be the contrarian of the day and ask as many inconvenient questions as possible. Like, who wants to live in a high-rise made of wood? Obviously, the first question you get is, what about fires? Now, I'm willing to listen, but I have to tell you, I'm already predisposed to believe that wood burns no matter what you do to it.
Okay, I'll handle that first, because I know Paul's also the expert on the design side.
We can both handle this one.
Yeah. With regards to mass timber, there is a series of testings done in both Europe and now in Canada that would show there's as much fire resiliency on mass timber as with any other system, any other component of construction. The mass timber will burn for about the first half inch. It'll char on the outside of the product, and depending on the dimensions, that'll still maintain its resiliency and its strength. Now, if you contrast that with, say, structural steel, under same intense heating of a fire in a high-rise building, that can have deflection and load distribution, you can see collapse in steel structural buildings. But I think what we really want to highlight with regard to fire in any high-rise building, the issue of your fire code, it allows people to egress the building that's under fire conditions. That is the main priority.
Get out of the building in time. Why? Why quicker that way than?
You can say, okay, on a mass timber construction, if you put 1 or 2 layers of drywall, fire rated drywall, you're going to get your 1.5 hour, your 2 hour fire rating. The main priority of any building is to allow people to egress the building in the conditions of a fire. It's not to say the building is structurally sound after a fire. That may or may not be the case in any building. It could be a concrete, it could be steel, it could be wood. The issue with fire is allowing people to get out safely of the building. So as long as you have a wood building with the appropriate fire code, that's going to pass any test with any fire department, any city planning commission, etc.
Oh boy! Well, you almost won me over. 1 or 2 more folks like you, and I'll be a believer. If you can confirm what he said, you're already half there.
Yeah, I can absolutely confirm what Mike just said, and how structural engineers approach it. If for the mass timber, we'll talk about a column. If for a column, structurally they need 10 inches by 10 inches of column, what the structural engineer does is he says, okay, now I want you to put in place a 14-inch by 14-inch wood column. That gives him 2 inches of char layer on the outside. As Mike said, tests have shown repeatedly that mass timber only needs the ½ inch of char layer. So the structural engineer is a little bit more cautious and conservative. He's going to say, give me a full 2 inches of char layer, because all you need structurally is the inner 10 inches.
Give me an image of. I'm racking my brain for images of forests after a forest fire. Don't those trees fall down?
Not always.
No, because if you're right, then the trees that have been through a forest fire should be still standing, shouldn't they?
Many are.
Lots are, certainly the main trunks of them. But a building is also very different from a forest. The forest, the tree is unsupported at the top, whereas in building, the column is supported both the bottom and top edge, so it's less prone to fall over because it's restrained at the top, whereas a tree is not.
I might also offer that, in Toronto, with our history of kind of post and beam construction, 120, 130 years ago, manufacturing facilities, if you look at Spadina, King Street, Queen, all those old buildings built probably 1880s, 1890s, 6 stories, post and beam wood structures. You go into some of those, you've seen where they've had fires. Yeah. And those columns have been burned. And if you look up at the ceiling, you can see all that floor slab. That had a fire maybe 30, 40, 50, 60 years ago. They scrape off the black charring, and the building carries on structurally sound. And now that those buildings are becoming for different uses, they started off as manufacturing and warehousing. Now they could be a hotel, they could be a restaurant, they could be an office building. So those buildings evolved, the uses evolved, but the beauty and the structural integrity is still there.
Okay, well, so we're going to start building more houses with wood, and the solution is plant lots of trees and cut them as soon as they get mature, or not before they get post-mature, while they're still
well, one thing I might respond, I think we're already building lots of single-family homes with stick frame, stick building. I think what we're seeing now is the transition in an area like Toronto, Montreal, Vancouver, where land is just too expensive to build a single-family home. So the approach now is to build maybe up to 6 stories and greater in mass timber as residential properties for much more. So it becomes a multi-family home rather than a single-family home. So if you take a look at major streets in Vancouver, Granville, etc., you'll see accumulations of properties where, 50 years ago, there might have been 3 or 4 single-family homes built. They merged those properties, and now they're putting up a 6-story or an 8-story wood building, multifamily. You'll find maybe 12 families on the property where before it might have been 3. So in terms of house construction, I don't think we'll see major changes there. Although as technology is always developing and evolving, it could be prefabrication, etc. But primarily, I think with single-family homes, you'll probably still see the traditional stick-build type of development construction for the next for the foreseeable future. Do
you find people resisting thinking that living in an apartment is somehow substandard? People living in apartment buildings should be pitied because they can't afford decent housing. I don't feel that way, and I never have. I like living in an apartment building because it's a lot easier on me. I don't have eavesdrops to worry about and things. But also, I think environmentally, it seems to me it's far better as a source of, preventing emissions of greenhouse gases. Is that right?
Oh, definitely. When you put people into apartment or condo size living units, definitely there's less carbon emissions per person in that sort of arrangement. Mm-hmm. And I think when you talk to most people nowadays in their 20s, early 30s, they're not looking towards single family dwelling. They are looking positively towards living in apartments. Mm-hmm. It is a new way of living, and other cities have gone through it before us. London, New York, Hong Kong. Toronto's just next on the list, where we have to adapt the way we live to greater density to accommodate the people we have here.
Well, let's talk about some of the bads. You mentioned concrete and steel. I don't know much about steel, but maybe I keep looking. I actually look it up every now and then. Do they have any good solutions for concrete? What's the story with concrete? It emits, automatically emits carbon, right? You can't get around it?
Well, in the manufacture of the Portland cement, which is the chemical binder within the concrete is made of sand, gravel, water, and Portland cement, or some other chemical that's the binder. So in the making of Portland cement, you start with limestone, and you basically have to get from limestone to a powder. And how they do that is in great furnaces. And so that's the point at which the carbon is being emitted to the atmosphere, because it takes so much heat to turn limestone into Portland cement, into the powder. There are other ways, there are other materials you can use other than Portland cement. The Romans used volcanic ash instead of Portland cement, and Roman concrete is far better than modern concrete. So we just don't have the ready supply of volcanic ash.
I saw something called fly ash.
Yeah.
What's fly ash?
So fly ash is the material that's essentially scraped out of the inside of the chimney from the steel making industry. So it's a waste product from the steelmaking industry that then can be used to replace 75 or 80% of the Portland cement in concrete, and it produces better concrete.
Is it a lightweight process as well? Is it a lightweight concrete?
It doesn't make it lighter. It doesn't make it, so far as I know, it doesn't make it lighter, but it just makes it stronger, faster.
So a question is something we should wish for? Sounds like maybe not, because the only way you're going to get it is from some other bad deed.
Exactly.
Yeah.
It's better than doing bad twice, but you have to do bad once to get. But at least you're not doing bad twice. So there's a benefit there. Okay,
so there's nothing on the horizon for a really good replacement for concrete.
Yes, certainly the concrete industry is doing everything that they can to lessen their bad. They're creating concrete now where they inject carbon into the concrete, and they're also creating concretes that draw carbon into them while they're in place. So the concrete industry is doing everything they can.
And I think also in a city like Toronto, we have to recognize that we're among the top development side on concrete. I mean, the concrete buildings that we built, I mean, and also I will say that the carpenters are very proud to have built those buildings, have a great history there. So we want to maintain an understanding of how the industry is changing, how it's evolving, but we recognize that, look, concrete is still the backbone of the construction industry and will be for the foreseeable future. So wood is in infancy, and it's really growing, but I think you can't walk away. You can't ignore that concrete is still the main structural component in the cities that we live in and we build.
You know, one of the things that we worry about is deforestation. And there is a gradual loss of, I've forgotten how many million trees per year. On the average, we're going downhill instead of getting better. Well, maybe in the last year or two, I don't know. But at any rate, until recently, at any rate, we're losing a lot of forests. And we need something like 1 trillion new trees in addition to the 3 trillion that exists now on the planet. So how are you going to get all this wood?
Well, that may well be true that deforestation is happening, but I don't think that it's happening in areas of the world that have, like I said earlier, a proper forest management system. You know, sure, I agree with you. Deforestation is happening, but at the same time, what else is happening in those particular countries? I mean, so like I say, if I was to look at France or Germany or Austria and say their policies around rebuilding their forests for each tree that they're cutting down, they're planting numerous trees and having them properly managed over the next 15, 20, 30, 40, 50 years. So I wouldn't say that deforestation is happening in that geographic area. So yeah, on a global scale, I wouldn't argue with the point.
From what I understand, you hear a lot about the deforestation in the Amazon basin, and that's a lot of deforestation for the purpose of agriculture, either growing palm oil crops or cattle grazing. So they also say quite a bit of it. Right. I talked to one guy who said a lot of it has to do with the building a lot of dams also, which ruin land.
Yeah. That may be the case. That has nothing to do with what we use for the mass timber industry. I mean, like, it's a minute amount of lumber and timber that goes into that industry currently. And like I said, for the next number of years, it's going to remain pretty small.
Now, when you talked about this lamination, like the Austrians are good at, you say they're good at that. What is it? What do they do? You're gluing pieces of wood together, and that makes it like as strong as a whole real piece of timber, or not?
Well, fair enough. Okay, so what I might do is I might ask you to imagine a piece of plywood. So 4x8 sheet of plywood. It may be comprised of a number of laminations that are about 1/16 of an inch thick, and maybe there's about 6 or 7 of those laminations or so, and then they're at a 90-degree angle to each other. So then if you look at a cross-laminated timber or the kind of mass timber that we're talking about, we're not talking about laminations of a 1/16 of an inch. We're talking about laminations that are 1 inch or 1.5 inches thick each. So if you want an 8-inch piece of slab, floor slab, maybe 8 inches thick, comprised of 5 laminations, 1.5 inches each. And that lamination might be 30, 40, 50 feet long by 8 feet wide.
So you can make it as big as you want.
As big as you want. As a matter of fact, that's pretty well the way they do it in these factories. The factory doesn't work off of the final product. The factory works off, this sheet is maybe 100 feet long, 150 feet long, and they cut it up as they require it. But they need a 20-foot length.
Okay, what's the glue?
It is a glue, so I'm not really familiar with that aspect of that. We did have some questions around the off-gassing of it in terms of air quality and the flammability of the glue. And they're saying through their testings that it's a higher quality, say, for instance, than what we might know in North America, formaldehyde glue, that sort of thing. So they're saying it's safer, it's less, it's more resistance to fire. So, in a Canadian context, we see that there's huge opportunity for Ontario. I mean, if you go back 30, 40 years ago, we had multiple mills in Northern Ontario that are now closed down. Why? Because the pulp and paper industry has had to slow down. The timber industry has had to slow down. So there's huge opportunities there. So right now we have multiple mills that are closed in Northern Ontario, and we're saying let's reopen those, but use those not for pulp and paper to make toilet paper. Let's use them to manufacture wood products, mass timber products that can be used in the construction industry. That puts people back to work in the manufacturing side. It puts people back to work in the forestry management side. So there's lots of opportunities to say, okay, as an industry evolves, how do we make the best of it for the province of Ontario?
Nothing wrong with that. Looks to me like, what did you go out there to get, Paul? You came back with
I brought a piece of show and tell with me. So, it's not only glue that holds these pieces of wood together. So this sample here comes from an Austrian company, and it's made up of 1, 2, 3, 4, 5 layers symmetrically, and it's held together with dowels. So not only held together with glue, but this particular system is held together with wooden dowels. So it's an all wood solution, no gas, or no glue to off gas.
No glue at all in there.
No, there's no glue at all in here. Oh. So that's one solution, and the dowels look like this. Wow. They're just wooden dowels. But also, those older buildings at Spadina and King and those areas that Mike talked about earlier, with all the wooden decks in them, the wooden floors in them, those were what was called nail laminated timber. So they were just 2x4s or 2x6s put up against each other, and every one is nailed to the ones that went before. So no glue in those either, but nails used to hold them together. So there's a number of different ways you can engineer this wood together. As Mike said earlier, the Austrians are very good at taking small pieces of lumber and making big pieces out of them, as opposed to our Canadian penchant for taking big pieces of lumber and making them small.
All right. Well, good. Fine. Now we've handled concrete with not much satisfaction, I must say. But now tell me about steel. What's the matter there? And is there any prospect of using less steel? And what would you use instead? I mean, for building, I understand you want to use wood, but there's a lot of other stuff that requires metal. Are there any forms of metal that we like better than steel?
Well, I mean, I guess I can respond. Look, to be quite candid, if I look at a store like one-story commercial store, a Loblaws or a Canadian Tire, something like that, red iron, so if it's exposed, it's not a very elegant solution to the construction component. It's pretty inelegant. I mean, so if you have wood as an alternative, post and beam wood looks fantastic. So there's some, in terms of the beauty of the finished product, I think wood is far superior. So, I mean, I guess it depends on what the client wants at the end of the day, what the expectations are, and then how you design for that. So my argument is that I prefer to see more mass timber involved in terms of and then a red iron solution. But
sorry, red iron.
Red iron is steel, structural steel.
Oh, okay. And you don't like it. You want?
Yeah, no, I mean, yeah, I think there's better solutions in the industry than that.
Okay.
But it has its place. I mean, if you're looking at a warehouse, why wouldn't you use structural steel? That's fine. You know, it's just kind of it's a boring solution to a need, but it has its usages. No question about it.
Mm.
But if you want something that humans interact with and humans take joy in,
yeah,
wood will be better than steel. There are studies that show, if your skin is in contact with wood, you are healthier and happier. That's part of the reason why here in our office we changed all of our desktops to untreated wood, so that our hands, the skin of our hands is in contact with wood. Very unscientific study. We all seem to be pretty happy around here. So.
Well, you didn't have to convince me of that, because I would agree with you that it is more pleasant. There is something very, I like the idea of doing that. But I don't know. Now, let's go back to this thing of how fire and steel. Did you say, Mike, that I think a while ago that sometimes steel buildings melt too? That's what I'm.
They wouldn't necessarily melt, but under intense fire conditions, the load that's on a steel beam, it can cause deflection in the steel. They wouldn't melt, but they'll lose their capacity.
So that it would be unsafe.
Yeah, so it causes structural failure.
Uh-huh.
And then also with steel, like a lot of people nowadays think that, if we want to build something big like a bridge, it has to be steel and concrete. And yet you look at railway trestles that, many of them in the early parts of the 20th century were built out of mass timber, and they're still there, and trains run over them, and trains are not light.
Uh-huh.
And something that moves like a train causes very dynamic movement through the structure of the train trestle. Doesn't bother the train trestle at all.
And in terms of the labor, how much difference is there between various methods of construction?
If it's mass timber, for instance, what you're doing with mass timber, you're transferring some of that labor into a more controlled environment, like a manufacturing facility, a factory. You're manufacturing components that are then shipped to the site, and they're installed rather than fabricated. All the fabrication is done in the factory. So it will impact on the labor side, but it's a shift of labor from the site to the factory. As I mentioned earlier, it's a more controlled environment, weather, etc., health and safety. So that's actually can be seen as a positive thing, because some of the issues that we would have in the Canadian context of construction is the weather issues, and whether it might slow down the process of construction. It may leave, if you have lots of water on the job site, it impacts on the wood structure, etc. So
you can't build wooden structures in bad weather.
Well, you can, and that's exactly the way the Canadians have been doing construction for the last 150 years. And that's one of the issues that I even have with the way that we with our housing market. Right now, you're building a single-family house, you're building it in the wintertime, there's ice and snow and rain, and then when you enclose that property, as we go forward, as the construction process goes forward, you still have huge amounts of moisture inside a single-family home. You have issues with mold. You have issues with air quality. You have issues with bacteria growing in the wood. So there's huge issues in the way that we build. And I think that this a shift to mass timber may force us to address some of those issues in the way that we build, in the way that we do construction. Mm-hmm. If I look at Europe, they enclose buildings in a structure, and they build inside a tented-like structure. So it's a different approach, and I think it's a better approach to the construction industry.
So that the wood isn't exposed to the elements while it's under construction.
Mm-hmm. Okay, tell me about brick, because I see out behind me a lot of houses made of brick. And I think they're still putting them up, aren't they?
That is true.
Is there any loss of interest in brick housing?
I think if we look at Toronto, we have a great history of brick, but I think primarily, even in the city of Toronto, where we're known for our brick is not so much a structural element as it is a veneer element. So the structure of buildings, like we talked about that King and Spadina area, that gorgeous old buildings. It was a post and beam wood structure with a brick veneer, maybe 2 layers of brick. The majority of the homes in the Toronto area, even though if you go down to Cabbagetown and those areas, beautiful brick buildings, but it's a brick veneer. It's a skin of brick on a structure of that's in single family home. It was 2x4s, 2x6s, so it's a wood structure with a brick veneer, brick skin on the side of the building.
I was not brought up in Canada, and I believe I read that there'd been a fire in Toronto long time ago, and they passed a law saying that all houses had to be made of brick or not wood. Now, but what you're describing, if the house structure is really wood anyway, and the brick is only, cosmetic, does that really affect the fire resistance?
I wouldn't necessarily call it cosmetic, because it does play a role in protecting my house if your house is on fire right next door. So even as we go forward now with a 6-story wood structure, the code is saying we need non-combustible cladding on the exterior of the building. So that could be a metal panel, it could be a cement fiber panel, it could be brick. And so you'll see a number of different applications of a non-combustible cladding on the exterior of buildings. So in the case of code, I mean, Paul can speak better for that than I can, but it has a lot to do with protecting my building from your building if your building is on fire.
That's precisely it. A lot of it looks at the protection of the neighboring building. That's what the code is looking at. So in the Great Fire of Toronto, the fire spread from one building to the next. So that's what they were trying to prevent. Now, to say that these buildings were made of wood is absolutely true, but they were made of very small pieces of wood. So they had no char layer. So, wood siding and wood 2x4s burn very quickly. We're talking about mass timber. We're talking about, things the size of this in section, whereas the outer layer may char, the inner structural layer will be unharmed.
That's about 8 inches apart, thick or so, isn't it?
That's right. So that's the big difference. All wood is not the same. When we cut it down into matchsticks, then it burns quite quickly. It becomes kindling essentially. So.
Okay, now let's talk about the exuding of greenhouse gas from buildings, or the heat and cold. For example, my high-rise building here is a brick one, and they've been driving me crazy the last year, going around pointing the bricks. They have to climb up and, I guess, stick new mortar in there or something. I don't know what they're doing. But the building next to me has done something fancy, and I was watching them all last year. They had guys come up and they glued on something on the exterior of the building. It was a brick building, but they put something out, attached it. So it looks different. It's kind of same color, but it's definitely a different texture. I presume that this was an effort to reduce the transfer of heat through.
Maybe and maybe not. It depends whether the brick is a brick veneer, and when it's a brick veneer on more modern buildings, the brick is separated from the inner part of the building by an airspace, which allows the brick, the space between the brick and the building to dry out. So if they're just putting something on top of that brick that has an airspace behind it, if they're putting insulation on there, it's having not the best effect because the airspace is still vented, the cold air can still get in there. If the brick is directly adhered to the building and there is no airspace, and they do put insulated panels on the outside of that, then it's doing an effective job. So not knowing the details of the building section, I'm not sure. But I have seen a lot of brick buildings where the brick has become damaged through freeze-thaw because water has been allowed to get in. It freezes and thaws in the wintertime. It spalls, or the outside face of the brick becomes unsightly. And often they're just covering those buildings in metal panels to make them look better. They're not aiming at making them better thermal performance. So there could be a number of factors at play in this building across the way from you that we don't know.
I had the idea that this was the way of the future, that maybe next year they'll be doing it to my building or something, because I assumed that maybe the building codes were changing to require more insulation.
It is true, but the building codes don't work retroactively. They don't force existing buildings to come up to code unless an existing building is changing its use or changing in other substantial ways. So, but a very proactive landlord who is interested in reducing the utility costs of their building, they would very much look at putting insulation, putting overcladding on the outside of the building, wrapping the building in a good sweater as it is. So, a forward-looking landlord would be doing exactly that.
Hello, cat.
There's the cat.
Who is your cat?
His name is Nero, affectionately known as the Prince of Darkness.
Come on up, Nero. He's coming right to the camera. Now look at me. Come on, look at me.
Yeah, he does nothing on command. He does his own thing.
Well, it's just lovely to have a cat. I don't have one. Yeah, I have a friend who likes to spend a lot of time complaining about these tall buildings that are made of glass, and all walls of glass, and how bad that is in terms of loss of heat.
Yeah.
Tell me about it.
Okay, so yeah, definitely glass is windows are the weakest point in any wall system from a thermal point of view, definitely. And yet, people, and all of our clients, keep insisting on having them. Don't know why people want all these windows, but they sure do. People are strange that way. So we improve the windows. We make them, the industry makes them as good as they can. Upgrades in the energy code built within the building code, they drive the improvement of window systems. Best window systems in the world now are coming from Europe because they have the most stringent codes. All those are good things. But when you look at a condo tower versus an office tower, from the outside they look very much the same. They're tall towers covered in four sides in glass. The difference is that the office tower is usually covered in what's called curtain wall, and I'll get to the importance of that in a second, whereas the condo tower is covered in window wall. And the big difference is the curtain wall is hung completely outside of the structure of the building, the concrete floor structure, those sandwiches that appear. Whereas in a condo, the window wall is inserted in between those layers of concrete, the concrete floors. So the concrete.
I'm trying to visualize this again.
So it's a little bit complex, but in the office tower, the edges of the concrete floors aren't exposed to the outside because the curtain wall hangs outside them. It's a much better construction in an office building than the construction in the condo tower. The condo tower is much less expensive.
I heard somebody say that if you have steel beams going out into the weather, it's going to conduct cold into your building. Is that what you're referring to?
The opposite way, it's going to conduct heat to the outside. Law of thermodynamics is heat moves. So you always have to think of the heat moving. So the heat will be transmitted from inside the building to outside. It's what's called the thermal bridge. And those concrete floor slabs do exactly the same thing. They are thermal bridges to the outside. So an office tower will perform better than a condo tower will when it's built with curtain wall versus window wall. And yet there are ways we can deal with this. But the interesting thing is that when you look at the performance of, okay, so you say, yes, a condo tower is not a well-performing thermal building because it's all covered in glass. Fair enough. But now look at the performance of that building relative to the number of people that are housed in it. So look at heat loss per person housed, and when you look at the same number of single-family dwellings in Markham, say, that house the same number of people, the heat loss from all of those single-family houses is way greater than from a condo tower.
Yeah.
So condo towers are still more efficient than the equivalent number of single-family houses. Now, that much said, condo towers could be much more efficient still. They could be better built.
But besides that efficiency element, there's the land use. I mean, I just get annoyed with people who want all these empty backyards. I don't know why anybody wants to have to mow all that stuff and get no value from, as far as I can tell. I have a balcony, and that's more than I can use. I don't need it very much.
But Metta, I might ask Paul to kind of expand on that discussion just around how it would apply to something like the tower renewal program here in Toronto. So that's a way to take a look at those older buildings, residential, that might have been done in the 50s and 60s after the war, and then how do we rehabilitate, renovate, rejuvenate those for greater and to maximize our energy conservation. So then, Paul,
are you saying a tower? Let me get it. Make sure I hear you. A tower renewal project? Is that what you called it?
Tower renewal program. As a matter of fact, under former Toronto Mayor David Miller would have been known as the Mayor's Tower Renewal Program, but I think they just call it Tower Renewal currently.
Yeah.
Okay. I had never heard of it before, but
yes. Yeah. So the idea there is taking the 1,000 apartment towers that were built in the Greater Toronto area, or the 2,000 towers that were built in the Golden Horseshoe in the 50s, 60s, and 70s. In our Golden Horseshoe area, we have the greatest concentration of apartment towers in the world. So we have a lot of them, and they were all built between the 50s and 70s, and there wasn't a lot of thinking about thermal performance in those days. We started thinking about thermal performance in around about 1974 with the oil crisis. Mm-hmm. And so the majority of these apartment towers were built before that. So the idea is looking at these apartment towers and saying, okay, they're under single ownership, a landlord owns them, and therefore they can be overclad with insulation to make them perform better. We can replace all the windows because they're probably the poorest performing windows ever imagined in these towers. And so let's replace them with state-of-the-art windows today. Maybe not the Rolls-Royce of windows, but a good, dependable Honda of windows would be better. And they're even looking at cutting off the balconies, because those concrete balconies are just an extension of the concrete floor slabs, which is going out. And there are wonderful memes going around the internet which show, the best German engineers that designed a motorcycle radiator. And, and this thing was designed to eject heat from the motorcycle engine as efficiently as the best German engineers could come up with. And you look at a picture of a typical apartment tower with the balcony sticking out, it's exactly the same. So the best German engineers could not come up with a better building.
Well, I'm living in one right now, and I hadn't even known that. And thank you, but I don't thank you. I don't want to know that. What can you do about it? You want to take my balcony away from me? I don't use it much, but I really would miss it.
Yeah, but what they do is that, again, these very clever German engineers have come up with, when they build new buildings, they thermally decouple the balcony from the floor slab. So the idea is, on these apartment towers in Toronto, we would cut away the existing balconies, and then we put back a new balcony that's thermally decoupled from the interior floor slab. So we're not allowing the building to continue to be a motorcycle radiator. Mm-hmm. So those are the kind of things that we're looking at doing with this tower renewal, to make these 1,000 or 2,000 towers much more energy efficient. I mean,
is this a real plan, or are you just daydreaming?
No, it is a real plan. That is exactly what the tower renewal program at the City of Toronto, that's what the City of Toronto is working with the landlords of all these buildings to incentivize them to do this work.
Well, it's a condo in my case. Same deal, right? Is it financially, is that any different?
Condos are a little bit different because these rental apartment buildings have a single owner, the landlord. In your condo building, each unit is a separate owner. So all the owners have to agree to do this in a condo.
Now, there's this weird rule about condos, which is that anything that's inside the wall of my apartment is mine, and I have to take care of it. And anything that's on the outside is theirs. I mean, belongs to everybody. So I believe the inside of my front door I can paint, but they have to paint the outside of it. And if that's the case, then the balcony should belong to them. That is us.
Yeah.
Does that resonate? Anything you've ever heard?
Yeah, that makes complete sense, and that's why you have a condo board that makes a lot of decisions. But if it came to the decision to spend the amount of money to overclad your building and cut off the balconies and put on new balconies, that would be a lot of money. That would probably, the board would not make that decision on their own. The board would put that to a vote to every resident in your town.
They would anyhow. I mean, every owner would have a vote anyway.
That's right. That's right.
Yeah,
so then either 50% of the owners would have to agree, and then it would pass, or it would have to be unanimous, whatever the voting structure of the condo board is.
Mm-hmm. Okay. Now let me move to an issue that I cannot find good answers to, and I've actually phoned the University of Toronto's engineering departments, because there are about 6 or 8 different engineering fields, and they have their own departments. And I said, who do you have that is a professor of refrigeration? Where can I find out about refrigeration? And they say, we don't have anybody teaching anything like that here. And I don't understand that, because somebody has to know the physics of coolants and stuff. Because in my drawdown book, which is my Bible, of all of the things that I think every good environmentalist should memorize, what they did is they made a list of 100 things you can do, interventions that can be done that will reduce global warming. And then they calculated how much it would cost to do each one, and how effective these interventions would be under varying degrees of commitment. I mean, business as usual versus try a little bit versus try your best, And that made them, they came up with real numbers, and then they rank ordered all of these things. There are about 85 things that all are worth doing, but some of them more so than others, and they can tell you how much more so. And just guess, maybe you will know, but nobody I know has guessed this yet. What is the most powerful thing we can do to reduce global warming? The one most important intervention that we could make.
Refrigerant management.
Right.
Yeah.
And my jaw dropped. And, and when I talk to people about it, nobody has ever heard of that. And what is the implication for, my first thought was they had this meeting. It was a follow-on after the meeting in the Montreal Protocol that phased out the chlorofluorocarbons to protect the ozone layer.
Correct.
And then they find out that the stuff they're using instead is just as bad or worse for global warming. That it's thousands of times worse than CO2. And look at all of the air conditioners and refrigerators that are being created around the world. So my first thought was, let's have a law that says that if a guy delivers a new refrigerator or air conditioner to your house, he has to take the old one away to a place where they have skilled people who will take that gas out instead of allowing it to accidentally get out and into the atmosphere. And somebody tells me that there really is such a law to that effect. Is that true? I haven't been able to find anybody who knows anything about this.
I wouldn't know.
I would hope that there's a lot of that effect, but it probably, it may not be very well enforced when it comes to those sort of individual air conditioners at your house. But the real, refrigerant users are grocery stores and places like that. All those fridges and freezers in a grocery store, they are huge users of refrigerant. And the trouble is, with these gases that you're speaking of that have this tremendous global warming potential, whenever there is a leak in there, then they have to close down the facility. People have to get out and they have to deal with it as an emergency situation.
Oh.
The interesting and very paradoxical thing is that a better refrigerant gas is actually carbon dioxide. So we can draw down carbon dioxide, use it as a refrigerant. If it happens to leak, well, it goes back to the atmosphere where it came from. Oops. But, it's a zero-sum game. We took it from the atmosphere and oops, we released it back. Oh, sorry. But it's not poisonous to people either. It's just carbon dioxide.
Why aren't we doing it then? I've read the names of all of these weird new things, which I understand. The thing I read said that the newer things, there was a meeting in Kigali, Rwanda, a couple of years ago, and they're going to phase in new rules for new air conditioners, but it's not operative yet. And we got to watch out, whether they're really going to do this. And in the meantime, I'm worried about the old ones. What are you going to do with the old ones? But the report said that they agreed on some new chemicals that are to be used as a coolants, but that they're not very good. They're not as effective as the old ones. I thought one of them was ammonia.
Yeah, ammonia is definitely one of them. And you can imagine that if there's an ammonia leak, you have to get out of the building really fast.
Right. Okay, well, now, I did not read anything about CO2 being a good thing. How could you use it for, because CO2 doesn't cool you, does it? I mean, if you have
the gas in and of itself doesn't cool. What the gas does is the gas allows, the gas absorbs heat. Again, it's cooling is the removal of heat. Again, back to that law of thermodynamics, it is heat that moves. So think of your refrigerator. You're not injecting cool into the refrigerator, you're removing heat. And then you're ejecting heat from that coil on the back of the refrigerator.
I heard the word, this is kind of extraneous, but free association.
Yeah.
What's a heat pump?
Same sort of thing. Your fridge is a heat pump. So your fridge is the heat pump. The pump is going in one direction, so that the heat pump is pulling the heat out of the box of the fridge and ejecting it out the coil at the back. So if you want to use a heat pump to heat or cool a larger refrigerator, say your house, it's a box. So in the summertime, your house is in refrigerator mode. The heat pump is drawing the heat out of your house and ejecting it into the ground for a ground source heat pump, ejecting it to the air for an air source heat pump, or into a nearby body of water. And then for the wintertime mode, when you want to heat the box of your house, the pump runs in reverse and it pulls the heat out of the air or out of a nearby body of water or out of the ground, and it injects that heat into the house.
It sounds logical. Now, how is that different from other heaters or air conditioners? Or, I mean, I get the idea sometimes from what I read that heat pumps are better than something else, but I don't know what they're better than.
They're better than just about anything else. In that they have a coefficient of efficiency of a number like 3. So for every unit of energy you inject into the heat pump system, because the heat pump is run on electricity. There are pumps, there are motors, there are things like that. So for every unit of energy you inject into the heat pump system, you get 3 units of energy out of it. So that's a good coefficient of performance. And whereas if you think of an electric resistant baseboard radiator, which is your standard electric radiator. It's really just like a version of your toaster. Those coils in the toaster that heat up. Mm-hmm. They have a coefficient of performance of less than 1. So every unit of energy you put in, because you put a toaster in and it's you pushed it down and you're trying to make toast, you don't get as much heat out of that as the electricity that went into it. So that's where heat pumps are really, really efficient. And they're definitely coming into their own as air source heat pumps, especially. So we can eject the heat from our house into the air outside our house in the summer, but that's very effective. But even in the winter, down to -20, even -25 now, we can pull latent heat out of the air down to -20, -25.
Are you hopeful about the trend in terms of consumer openness to doing the right things in terms of buildings? Do you find people wanting old-fashioned balconies on their apartment building or whatever? Are you getting resistance, or what do you need to do to organize people and get people on board with doing the right things?
But 10 years ago, we put the name sustainable out there on the street, very clearly articulating this is what we do. Mm-hmm. And if this is what you want, this is where you come to get it. We wondered 10 years ago if there would be enough customers wanting to buy specifically that product. Well, 10 years later, we're still here. We've grown to an office of 12 people. We're still growing. So I think that the customers are definitely there. The right thing in buildings is no longer a technological challenge. We know what to do. We know how to do it. It is a social problem now. It's a lack of will, and it's mostly a lack of will from the government, from the leader.
Yeah. Well, the government is put there by folks like me, and therefore, I
we all are responsible.
need to inform myself. What do the carpenters feel?
We talk to the industry, we talk to the political leaders, so we hope to have some influence on, a positive approach on energy efficiency, but at the same time, we know that we have to educate that next generation that's coming up through the ranks. Mm. Our young people, our next generation, they're coming to me, and they're saying, Mike, how can we get trained for solar? How can we get trained for wind technology, for Mayor's Tower renewal? So I'm being pushed by my next generation. So at the same time, we're talking to political leaders and saying, we better get on board here. We better collaborate to make sure this happens.
Sounds like everything is happening that should be happening. My question is, how fast are we doing things? And, the IPCC says you got 12 years, guys, then it's game over. That's a challenge. Time's up. We got to say goodbye. This has been great fun, and I appreciate it very much. I'll send you the link to it. And,
perfect, Metta. Thank you very much.
All right. Thank you
so much. Thank you.
This conversation is one of the weekly series Talk About Saving the World, produced by Peace Magazine and Project Save the World. Please visit our website at tosavetheworld.ca, where you can sign the Platform for Survival, a list of 25 public policy proposals that, if enacted, would greatly reduce the risk of 6 global threats to humankind. Come back next week for another discussion of a serious global issue.